All right, ladies and gentlemen, if we're going to solve this quadratic equation by the quadratic formula, there's two things we need to know. First, we cannot solve the quadratic equation in this format. A lot of students will try to identify your a, b, and c from here, and they're going to get the problem wrong. They're going to get the problem wrong every single time. Because when we want to identify my a, b, and c, we need to know this. The values of a, b, and c are only going to be true for the quadratic formula, are only going to give us the solution that we are looking for when ax squared plus bx plus c is equal to 0. So we have to make sure we first, always first, is put our quadratic in this format. To do that, I'll just add a 5 to both sides. And now we're all set. The next thing is we need to understand, well, what exactly is the quadratic formula? Like, how to identify my a, b, and c if I don't even know what they're going to go into? Okay, so that's quadratic formula, and I always tell my students, like, don't memorize this, just do enough practice problems so that you have it ingrained. And then also that's gonna help you avoid mistakes, right? Because that's the number one thing students do. It's not so much that they can't do the quadratic formula, they just make mistakes doing the math. So work through multiple examples. Hopefully you can work through this example with me, and then there's multiple other examples that I have or from other creators that you guys can follow. So all we're simply going to do is identify my a, b, and c from here, and then we're going to plug them into this equation. So what exactly is my a? So my a is the coefficient of my x squared, which is in this case is 2. My b is the coefficient of my linear term, which in this case is 6. And c is going to be my constant, which in this case is going to be a 5. So now all I'm simply going to do is take these values and plug them into my quadratic formula. All right, so now we got to go and simplify. And when you're simplifying, ladies and gentlemen, just take it slow, right? I'll try to like explain everything that I'm doing, so therefore you guys can see and not be confused and be like, where did you get that number? Where'd that come from? That's like one of the top comments sometimes I get. And I always try to avoid it as a teacher because I remember when I was a student, I like trying to follow along, or I'd read like a textbook and then I'd see like they went from one step to another. I'm like, what happened there? So I'll try to make sure I can explain each and every step, and I'll try to show as many as I can as well. So I replace my b, my opposite of b, with a 6, right? So it's opposite of b, so opposite of b. And therefore now let's just kind of do our math here a little bit. So 6 squared is going to be a 36. And then here, I'm just going to multiply everything from left to right, and I'm not going to worry about the negative. So 4 times 2 is 8. 8 times 5 is going to be a 40. 2 times 2 is 4. Now, a 36 minus 40 is going to be a negative 4. Okay, now if you have not uncovered the complex number system, then you can say in this case, you cannot take the square root of negative 4, Ms. McLogan, so there is no solution. That means this graph does not cross the x-intercept. There are no x-intercepts of this quadratic. However, if you have been taught the imaginary numbers and you're familiar with the complex numbers, then what we can do is we can actually further simplify this, right? I can take the square root of negative 4 using our imaginary number system and rewrite that as a 2i. Now we recognize that we have negative 6 plus or minus a 2i divided by 4. Now it's very important to understand this 4 divides into both of these terms, right? So technically this is a negative 6 divided by 4, and this is going to be a 2i divided by 4. Now I can further simplify this, going right and going down. So 4 does not evenly divide into negative 6, but you can reduce that to a negative 3/2. And then 4 does not evenly divide into 2, but you can rewrite that as a 1/2i.